So this is where I think chemistry starts to get interesting. We're going to talk about physical and chemical properties of matter, right? So the characteristics that enable us to distinguish one substance from another are called properties. A physical property is a characteristic of matter that's not associated with a chemical composition. So examples of that are color, hardness, melting point, boiling point, density, conductivity, and so on, right? So we'll practice this a great deal. Physical changes then talk about or describe a change in a state or property that does not change its chemical composition. So wax undergoes a physical change when solid wax forms liquid wax, right? So you have both a physical and a chemical property going on here, or change. You have both a physical change and a chemical change going on here because the chemical is where it's burning, right? But the melting is physical. So a physical change is when it's a solid goes to a liquid, okay? Steam condensing on the inside. Can you see the dots of steam there on the inside of that pot? Those are, that's a physical change, right? Now, the change of one type of matter into another type is a chemical change, right? So examples of that are burning, or physical properties, I should say, is flammability, toxicity, acidity, reactivity, and heat of combustion, right? So these are examples of chemical properties, and chemical changes look like this. Or when I'm going back and forth between properties and changes, and I'm doing that because I'm not being careful enough, right? So one of the chemical properties of iron is that it's capable of oxidation. And there you go. All that iron that used to be beautiful is now covered with oxidized. It's iron oxide, which is not pretty. And then here's some metal which has not been oxidized, and it looks awesome. Chromium actually is not vulnerable to oxidation, and so we call this chrome. That's what we call it, right? And it resists turning ugly like iron does. Okay, chemical changes now. This is what I've been sort of anticipating with my misspeaking. Is chemical changes happen when you have a chemical reaction, essentially a chemical reaction, right? So here's copper and nitric acid undergoing chemical change. Here is fire. Here's some bananas. And here are, I think those are hot coals. I'm not sure what that is. Is that chicken? Can't tell what that is. All right. Whoa. What is that? I can't tell what that is. Well, let's look. C, cooking meat. Red meat. No, it's not chicken. It's beef. Okay. And that's because we have chemical changes going on. The color change is because we've got blah, blah, blah. All right. So now let's talk about extensive and intensive properties. We'll practice this a lot in class, so don't worry about not really getting a good grasp on this right now. Extensive property depends on the amount, and intensive property does not depend on the amount. So examples of extensive properties are how much mass do you have, or how much volume do you have, or how much heat do you have, right? But you would never say how much density do you have, right? Or you wouldn't say how much temperature do you have. Those are intensive properties. All right. And so I want to go back and look at the periodic table of the elements again. The author of the textbook brings it up again here. The periodic table shows how they're grouped according to similar properties. So these are mostly gases, right? These are entirely solids with the exception of mercury. This is another gas, right? And there's a liquid here. That's actually a liquid right there. That's a liquid. This is a solid, but mostly they're grouped together by their properties in the periodic table of elements. And there's other reasons why they're grouped the way they are too. All right, so we've gone over and we've talked about the physical properties, we talked about chemical properties, and we talked about extensive and intensive properties in Chapter 1, Section 3.